Okay, hello. So today we are looking at LeetCode 104 maximum depth of binary tree. So let us start with an explanation of how this works first. So let us copy over this binary tree over to a drawing board. Let's use this one. I'm just gonna give a few random values. 3. Oh, actually, you know what? Let's draw it here so we have more space. 9. It doesn't really matter what the values of the nodes are because, well, we're just figuring out what the depth is. So, yeah. Okay, so we have our tree right here. What we want to do next is think of how we can recursively get back our answer. So when we work with this kind of questions, usually we want to use recursion to solve these kind of questions. So and when we talk about recursion, we'll want to start thinking with the terminating case, right? So for example, at this node 4, let me just change the color. At this node 4, we would want to return a value of 1 since this is like one level, right? So same thing for here. And then when we reach node 20, we will want to return 1 plus another 1. So this is another 1. This adds up to be 2. And then when we return back to the root node number 3, we want to add another 1 to this again. Same for this. So in this case, the deepest depth is 3 since we have this 1, 2, 3 or 1, 2, 3, right? Okay. So terminating condition is obviously when if like say if the root dot left is, I'm gonna do pseudocode over here. Actually, you know what? It's none, and root dot right is also none, right? Then what we want to do is basically return 1. Okay. However, and then if let's say we are trying to return up, then what happens, right? We can just return max because we want to traverse both left and right side. We don't know at this point in time whether the left side is deeper or the right side is deeper, so we use a max function to figure out which one has more depth. So max of root the function, okay, this function, let's call it define get depth, pass in the root, right? So we call this get depth function again, right? We pass in root dot left. Remember to plus 1 to add on to the level because at each level you want to add 1 to it, comma, get depth root dot right plus 1, close bracket. Okay, so let's just see how this works, right? So I'm gonna change another color. Let us look at how this can work. So this tree at this point in time, at this position A, let's say, right, we have something like maximum of get depth root left. Okay, so at this point in time, it has not yet met the terminating condition yet. So what we want to do is basically get that call the getDepth function again recursively, right? So we basically do something like we are not sure what this function will return us, so we'll call this root.left. This is pseudocode, this is not the actual code. We want to find out the return value of root.left plus 1, and then return of calling the function on root.right plus 1, right? Okay, close this bracket properly. Okay, it's not pretty. Okay, so at A we do this, and then at B let's do left first, right? Because left comes first. Left, you get the terminating condition of 9 at node 9, right? So this node 9, it actually returns you value 1. Okay, perfect. So now we have the return of root.left done, and then now let's look at the return of root.right. So we basically do return root.right. We can see that at this root.right it's 20, node 20, right? Node 20 has not yet met the terminating condition, so that's why we again split it down to max of left. I'm just gonna do shorthand plus 1, and then right plus 1. Okay, so what is the return value of this? Let's figure that out again. Left.right, it returns us left is 4, right? It returns us a 1. Okay, we got that. And then right is node 5, it returns us a 1 as well. So now let us add up the values. Max of 1 plus 1 is 2. Max of 2 and 2 is 2, because left plus 1 is 1 plus 1 is 1, right is 1, 1 plus 1 is 2. Wait, 1 plus 1 is 2, and then 1 plus 1 right is 2 again. So yeah, we get this level. Let's change the color. This returns us to, oops, let's change this color to 2, right? And then 2 plus 1 is 3. 2 plus 1 is 3, yeah. So comparing max of 2 and 3, we return our final answer as 3. Okay, now that we have explained how the algorithm works, let us start writing our codes. Just gonna clear this. Okay, so terminating condition first. Oh no, you know what? Let us define the getDepth function. Return getDepth. Right? Okay. Define getDepth. Oh, you know what? I forgot the self root, and then getDepth. If root dot left is none and root dot right is none, what we want to do is return 1, right? Because that's our terminating condition. Else, yeah, no, not else. Yeah, that's the terminating condition. And then we want to return maximum of self.getDepth root.left. Remember to plus 1 to add on to that level. and then self.getDepth root.right. Remember to +1. Okay, so let us try running this code. Okay, looks like it worked. Okay, so none type has no attribute left. This happened because we have met the condition whereby it's something like I'm drawing right. Okay, something like 1, oops, 2, and you can see that because this condition at this node, we have not yet met the terminating condition, right? So we continue with it. So we traverse, figure out what is root.left, but root.left is actually none, right? So we need to add in another condition that basically catches this null node. So if root is none, return 0. Let's try submitting that again. Alright, so looks like it worked. Okay, so thank you for watching my video.